Number 7. This is a question related to trigonometric graphs, and a lot of my students are having difficulties with this topic. Where I found this topic is easier than any of the other topics, or this question easier than any other questions in the pure mathematics 1. So everything we almost do in this question, or a question like the trigonometric graph, is just we do a main idea. There's nothing completely changed. There is no super hard shiftings, or there's no super hard different period of the graph or anything related to that. It's just that all you have to know, you need to know the parent function and like a lot of information about the parent function, and then you just need to see how much it differs from the parent function, the given graph, like how much it differs from the parent function, the given graph I'm talking about. Okay. Well. So if you're still having a difficulty, you just basically say to yourself, oh, I study very hard the graphs of trigonometric functions. We are doing the 3 of them, by the way. Sine, cosine, tangent, and you know every intersection, you know the period and amplitude and the maximum and minimum, etc., and you're still having a difficulty to solve the questions like this, that means you're having a problem to understand the topic called the graphs. Okay, so the topic we did the graphs like a cubic, a quadratic. So there was something that we were doing, analyzing the graph. We were just reading the graph, and then we are finding equation from the graph or intersections with the maximum, minimum, etc. And the same as here, but just a trigonometry. If you don't really understand this one, after you very hard studied the trigonometric functions or graphs, you should be going back and revising the graphs. Anyway, okay. So they say this is the graph of over here, the graph of y equals to negative 4 cosine x. Okay, if you know the graph of cosine x, roughly speaking, let's imagine that's 1 over here. It might be a little down. It's just something gonna look like this. Imagine. Right. So actually, yeah, probably it's gonna be something like this. Let's imagine like, okay, just let me just take it from that side. So that's gonna be 90 degree, and that is going to be 270 degree. There will be 180, and let's say 360 degree over here. Okay, the graph will look like this. So why I'm doing this, that gives me an idea that graph of cosine x has the same intersections with the negative 4 cosine x. You can actually find the solutions for negative 4 cosine x by just equalizing it to 0, and it will have the same solutions as the cosine x. Okay, so by doing so, like I just realized that the difference is only this graph. It's just the reflection of the cosine over the x-axis, as you can see, the reflection, and the maximum minimum changes is because of the 4 multiplied by 4. Okay, so I can actually sketch here negative cosine x. So if I'm going to sketch here negative cosine x, not necessarily, and imagine it's going to be something look like this. Okay, so just like roughly sketching. Okay, so what do they want us to do is they want us to find by the way, x is measured in radians. So for example, that's going to be a pi over 2, the first intersection. Okay, and we need to find the points P and Q. Points P and Q lies on the curve. We need to find the coordinates of P and Q. So coordinates, which means we need to find x and y both. Okay, so it's just like simple logic. Like if this is remember that is a periodic function, and periodic function means after certain points keep repeating the behavior. And for the cosine and the sine, the period is 2 pi. So on both sides are negative or positive. So it's basically until here, and then they're gonna keep repeating the same behavior and behavior. Like for example, from that point it's gonna go down, and then up and so on. Okay. So what I want to try to say is this 0, and then this part is reflection on the other part. It's just that's going to be, this is 0. That's going to be, this is pi over 2. That means this is negative pi over 2. So if the cosine x itself is getting a maximum at maximum at 0 and 360, actually let me say it in this way, minimum at 180, because cosine at 180 is -1. You can calculate this. That means for the negative cosine x or -4 cosine x gets a maximum, because it's just a reciprocal, not a reciprocal, sorry, like a reflection. It's like opposite the behavior. That means this is going to be a -pi. So this intersection is, cosine has an intersection, 0 at 90 and 270, so that's basically -3 pi over 2. You already guessed that's going to be, which is a minimum, supposed to be a maximum in the cosine, because it's negative, it's basically a reverse. That point is going to be a -2 pi. So we found the x coordinate. We can actually write down this one here, -2 pi for the x coordinate. And what about the y coordinate? It's not hard to find it. Guys, please be careful. Don't get confused. If you just sketch a line over here, that's completely not a -5. Some students going to write, oh, like -5, because it feels like a -5. It's not actually. You can actually see it from here. That must be either -4 or 4. Okay, so for the cosine x, let's say the maximum is 1 and the minimum is -1. For the -4 cosine x, minimum will be -4 and the maximum will be 4. So that means this is going to be -4 because it is a minimum over here. You see the minimum and then the maximum and then the minimum and etc. Okay, so what about the q? Okay, so for this I'm going to be cleaning this part away. So since we already did many things on the left hand side, so we just reflected the other side as just a reflection on the other side. Let's say the same behavior on the positive side as the same as negative side, but the negative values, positive values. Okay, don't forget this. All right, so that's literally an x intersection, which gives us the x coordinate, sorry, y coordinate 0. Literally an x intersection at what? 3 pi over 2. So like a 270 degree. Okay. So as you can see, the behavior of this -4 cosine x is almost the same as the cosine x, but the only difference is that multiplying by the -4, it only affects, let's say, outputs, not the intersections. So cosine gets 0 at 90 degree. -4 cosine also gonna get the 0 at 90 degree. Or let's say it gets maximum at, cosine gets maximum at 360 degree. Or you can single like 0, let's say, but this time it's going to be reversed. It's going to get a minimum at them. Okay, so part A, 3 marks. For me, it's from nothing, okay? It's like very simple. All right, here's the thing. The same graph, the same equation, which is -4 cosine x plus k, where k is, x is measured in radian, k is in constant. Given the C2, like this gives us, when you sketch it, obviously there will be up and down shift. It depends on the k value. Gives us the maximum value of 11. Okay, so I'm going to do a little investigation here. Let's say this is part B first. Okay, -4 cosine x plus k. So whenever the cosine itself, let me write it in this way, cosine x is defined between 1 and -1. This is the thing that you need to know from the basic cosine function. Okay, so whenever the cosine is 1, all right, so that's going to be -4. -4 plus something, not going to give us a maximum. Okay, so we are trying to make this, the whole thing, bigger and bigger and bigger. All right. So basically, it's basic simple idea. Even there is no cosine there. If it's like a -4x plus k, and we can say that the x is defined between -1 and 1, okay? So to make this expression maximum, that you need to take a negative cosine, which is -1, it's going to be. The reason, because negative times negative will be positive, and that means 4 plus k, whatever k is, can get the maximum, okay? All right. So when cosine x is -1, this expression will give a maximum value, okay? Sometimes you're going to be taking it 1. It depends what expression you have. Because of -4, I'm taking it -1. Don't forget, okay? So then 4 times -4 will be Negative 4 times negative 1 will be 4 plus k. So that's going to be maximum. And they say that's an 11. Okay? So they say that's an 11. So that means k is going to be 11 minus 4. What's 11 minus 4? It is 7. So the k value is 7. So then they say state the coordinates of the minimum point on C2. We're talking about this one where we found that k is going to be 7, which means I wrote it here is very ugly way. Okay, so which means, let me just put this here as well, which means the function or expression now is cosine x plus 7. Okay, we can write it. We found the equation. Okay, there's a stated the coordinates of the minimum point on C2, which is this one, with the smallest positive x coordinate. Smallest positive x coordinate. I'm going to go back to the function. Okay, so guys, we're talking about the minimum. Am I right? Minimum point. Okay, so positive one, we only need to focus over here. It's supposed to be positive. What else they say? Smallest positive x value. Okay, there is a minimum value over here, the x value minimum, but that's not a positive one because 0, at 0 it gets this. That means we don't consider this minimum value. We need to look at the smallest second positive. They cannot talk about the largest because that goes to infinity. So it goes maximum and comes to the minimum. So that is the minimum. All right. So we can actually do in the same graph. The reason we can do in the same graph because adding the 7 to negative 4 cosine x just takes the graph up and down, doesn't change the intersections. Okay. It actually changes, but like not that much. No, actually doesn't change it, I guess. Okay, anyway. Alright, so what I do is now, as I can see here at this point, it has the minimum value, right? So what is this one? We actually found it over here. It is 2 pi. Okay, so 2 pi is the point where this negative 4 cosine x plus 7 will be minimum. So they want us to find the coordinates of the minimum point. We're going to say it's going to get 2 pi. And to have a minimum, I need to take the cosine positive 1. Okay? Because if I take the negative 1, it gives me maximum. We talked about it here. Okay? I need to take the cosine positive 1. Or we just said that at 2 pi, like 2 pi, cosine 2 pi is 1, okay? So you can think of it this way also. Negative 4 times 1, where cosine is 1, plus 7, that's going to give us 3. So 2 pi and 3 is there. A minimum point, or the smallest minimum positive point, whatever they want, okay? You can say. Alright, that's the second part. It's done. So 3 marks. For me, it's almost from nothing. Okay. Well, a lot of students, when you see that they see the C part C, is like this complicated form of equation, let's say like 5 minus 10 over pi x. So they're like, oh, scared, and then cannot do that. Remember, the question has a 2 marks. That cannot be that hard, and you have done many things before that leads all the way to this. It must be easy, okay? And they don't say you what is the solution. They say number of solutions. So you need to know how many solutions are there. You need to indicate, show, giving a little reason how many solutions are there. Okay, the graph of negative 4 cosine x is given on the top. It's this graph. All we have to do is we need to sketch the graph of 5 minus 10 divided by pi x. Guys, this is a linear function. Okay, linear function. And the way we're going to sketch it, we are going to be finding the x intersection and the y intersection. And we need to look at how many intersections are there. And it's such an easy thing, you know. And this is linear, so if I want to find the y intersection, so y intersection, all I have to say x is 0. If x is 0, the y intersection is going to be 5. So all I need to go back, alright, there's a 5 over here and mention that on the top, okay? Don't convert this into a decimal when you're finding an x intersection. Instead, keep it in terms of pi. That's going to help you when you're sketching the graph. You're going to see in a minute. If I'm looking for x intersection, what do? Is I set the y0, which gives us 5 minus that's a 10 over pi x equals to 0, which means 10 divided by pi x is equals to 5. Let's multiply everything by pi and divide by 10. X is going to be 5 pi divided by 10, which is pi over 2. Okay, so pi over 2, we can actually indicate that is this intersection. So the graph, roughly sketching, is going to be something look like this. You should have your graph there as well to get in the full mark. As you can see, the 5 minus, let's say 5 minus 10 over pi x intersect with the graph of -4 cosine x at once. That means there is only one solution as graph intersects 1. Alright, so just a little bit of reason. If your graph is there, that's gonna be okay. Alright, so that's it. We are done.